Okay, thank you. I'm Inhwan from South Korea, and I try to share our experience to share what hydrological data set using Open API via IHP-WINS. So the Korea government is managing multiple water monitoring stations, and then they compiled all water data into the database, and then they share their water data through the integrated platform that is named WAMIS. So through the WAMIS, stakeholders and officers or researchers or company can take all water data from that integrated monitoring systems. So next slide. So here's the list of water data in WAMIS. The WAMIS is focusing on the hydrological data set. So there are hydrological data set, and also it provides water-related data set, that is information of watershed and river, and also hydraulic structures and water quality, and also it compiled the history of water disasters in South Korea. And among these data sets, we are sharing hydrological data using Open API service. So there are precipitation data and water level, and meteorological data and flow rate and suspended sediment are now sharing through IHP-WINS. So the Korean government encouraged to use Open API to access this water database. So company and researchers can develop their own water-related system using this Open API service. So through this service, we can share our data through IHP-WINS. So that is a list of our shared water data set, the precipitation and so on that I explained. Next, please. So this video clip shows how to access our data sets. You can find the data set through this featured data set list, and just to simply type the Korea, that typing window, and then please start the next video clip. Okay, yeah, it is starting. Yeah, you can just type in Korea, then you can find all uploaded data set by IHP-ROK. Their water quality and climate change projection, and some reports are listed in there. And at the top of the list, you can find the WAMIS data set. So next, please. So the first example is precipitation data. It shows the daily, hourly based data sets. And after setting the data range and set the specific time, then you can see the below the time scroll, they move the time scroll, then you can see the spatial and temporal change of precipitation across the Korean peninsula. So through this data set, you can find which area experienced rainfall or not. And then after selecting one water monitoring station, then you can see more detailed information of monitoring station, even though it is written in Korean. But, and then you can select that button, then you can download the all data sets in CSV format. Next, please. So the precipitation data providing daily and hourly based data sets. So you can select a specific point using the calendar system. So in case of daily data, you can find 3 months period of precipitation data. So after selecting month and date, and then you can find your interesting data set. And then in case of hourly data set, it provides 3 days of data set. So after selecting month, date, and hour, then you can find your interested time of data set. Next, please. And the next example is of the water level. And then same procedure, you can select the range of data, and then you can set the specific time. And moving the time scroll, then you can see the spatial change of water level before and after the rainfall. And also you can download the water data set after clicking that button, likewise the precipitation data. Next, please. So next example is meteorological data. You can find wind speed, and then the pressure of the air, and then average temperature across the Korean peninsula. And also moving time slide, and you can see the spatial temporal change of temperature or humidity, wind speed, and so on. And also you can download it likewise other data sets. Okay, next please. So the final example is for the suspended load. In case of this data set, the Korean government conduct the measurements after the big flood of South Korea. In usual, it is from June to August. There are big floods in South Korea. After that flood, the government conduct the measurements of suspended load to check out the geomorphological change after the big flood. So, and then after the measurements, they issue the paper, and then you can see the related, you can see the data set in that paper. So in this case, this is not the real-time data. So I'd like to show you how to visualize this data using graph function in the IHP-WINS. So after finding the graph type and set the x-axis and y-axis data type, then you can draw the kind of scatter plot. So in this example, I select the flow rate for the x-axis, and then for the y-axis, I select the suspended load or suspended load concentration. Then you can see the relationship between the flow rate and the suspended load from the data set. Next, please. So our next move is to link the WAMIS data set with the Open Learning course, because IHP-ROK are now making the AI learning course. And then using the WAMIS water data set, we are going to, we expect to enhance the learning efficiency using that kinds of data set. And then the next plan is to share the water data set for the Eco Hydrology demonstration site of South Korea to check the efficiency of IHP-WINS policies of South Korea. Thank you for listening.